These are the answers to Math 110B, Exam 4 at City College of San Francisco. Okay, number 1. Sketch the curve by using parametric equations to plot points and indicate with an arrow the direction in which the curve is traced as t increases. X equals 3 sine of t, y equals t squared, t between negative pi and pi. So here we are, made a chart. Okay. Negative pi to the x. Sine of negative pi is 0. Sine of negative pi over 2 is negative 1, times 3 is negative 3. Sine of 0 is 0. Sine of pi over 2 is 1. 1 times 3 is 3. Sine of pi is 0. And for t squared, you have negative pi quantity squared is the same as pi squared, it's about 9.9. Negative pi over 2 quantity squared is about 2.5. 0 is 0. Pi over 2 is 2.5. Pi is 9.9. So 0 roughly 0, 10. Negative 3, 2.5. 0, 0. 3, 2.5. Back to 0, 9.9. So it goes like so. Number 2, x equals secant t, y equals cosine t. 0 less than t less than pi over 2, not counting 0, not counting pi over 2. Okay, x is 1 over the cosine of t, which is 1 over y. So x equals 1 over y, or y equals 1 over x, which is what we're probably more familiar with. We made a mistake here. If we had t equals 0, which we're not, okay, cosine of 0 is 1, reciprocal of 1 is 1. So we have an open circle at 1, 1. And then t approaches pi over 2 from the left. Okay, so that would be like 89.999 degrees. The cosine, the y coordinate, approaches 0 from the right, which means its reciprocal approaches infinity. Okay, so that means the graph should go something like that. Number 3, find an equation of the tangent. X equals t squared plus 3t minus 2. Y equals t squared. You're given t equals 1. Plug in to get to point 2 comma 1. So plug in 1 here and plug in 1 here. Okay, so dy dt by formula is dy dx is dy dt over dx dt. So dy dt is 2t, dx dt is 2t plus 3. Plug in t equals 1. And I get dy dx is 2/5. So y minus y1 equals m times x minus x1. 4, find dy dx and d squared y over dx squared. So dy dx, dy dt over dx dt, dy dt is 4 cosine t, dx dt is negative 3 sine t. That can be rewritten as negative 4/3 cotangent t. D squared y over dx squared is the derivative of dy dx with respect to t divided by dx dt. Dx dt we already did. It's negative 3 sine t, so that's in the bottom. The top is the derivative of dy dx. So dy dx came out to be this. So what's the derivative of negative 4/3 cotangent dt? Positive 4/3 cosecant squared t. Okay, and 4/3 divided by negative 3, you can slide the 3 down as negative 4/9. And sine on the bottom means cosecant on top, so you end up with cosecant cubed. Number 5 is the polar graph. R equals 1 minus 2 sine theta. Maximum R is 3. I used the 15th circle. You can use the 12th circle also. But I would not allow just 3 circles. It's not using the graph paper efficiently. R equals 1 is the 5th circle. R equals 0.2 is 1 circle. Here's the chart. 0 to 2 pi. Plug in 0. Sine of 0 is 0. 1 minus 0 is 1. Also at 2 pi. Cut that in half pi. Sine of pi is 0. That's also 1. Then I do the 1/4 and 3/4 mark. Pi over 2. Sine of pi over 2 is 1. 1 times 2 is 2. 1 minus 2 is negative 1. 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times negative 2 is 2. 1 plus 2 is 3. Then all the in-betweens have something to do with radical 2 over 2. Sine of pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 all have a radical 2 over 2 in it. If you cancel the 2, you have a radical 2, either plus or minus. That's about 1.4. So you either have 1 minus 1.4, 0.4, or 1 plus 1.4, 2.4. Okay, we can reason it out. If you go from 1 to negative 1, negative 0.4. Go from negative 1 to 1, negative 0.4. Go from 1 to 3, 2.4. Go from 3 to 1, 2.4. And you know you're going to pass at 0, so it is a good idea to solve this for 0, just to see when you come into the pole. 1 minus 2 sine theta is 0. Sine of theta is a half. That's pi over 6, and 5 pi over 6 is when we come into the pole. Okay, so 0, 1, that's over here. Pi over 4 is negative 0.4, so you're supposed to aim at 45 degrees. You back up here. So that means you come into the pole at pi over 6, and then you come over here. Then pi over 2, 90 degrees is negative 1. You're aiming there, but you come back here. Then 3 pi over 4, negative 0.4, so you're aiming that way, but you walk back to this point. Okay. And by the time you reach pi, you're out at 1, so you come out over here. You come into the pole, again, at 5 pi over 6. So you come in and then go back over here. The rest is pretty straightforward because all the r's are positive. 5 pi over 4, 2.4, so 5.4, 2.4. 3 pi over 2, you're out at 3. That's the 15th circle. So you can see I didn't bother drawing the 15th circle. I only have to come out here once. That's out here. And then 7 pi over 4 back to 2.4. And then back home, 2 pi, you're back at 1. So you're over there. So that's the polar graph. Okay, number 6, you don't need a polar graph, but you do want a quick graph. Find the area of the region enclosed by one loop of r equals 3 sine 2 theta. So a quickie graph, I just said what happens at 0. 0 gives me 0. Pi over 4. If I plug in pi over 4, I'm doing the sine of pi over 2, which is 1. 1 times 3 is 3. Pi over 2, I'm taking the sine of pi, which is 0. Okay, so between 0 and pi over 2, I get one loop. Goes like so, and we're asked just for one loop. So it looks like I'm going to integrate from 0 to pi over 2 of 1/2 r squared d theta. So here's the original r. Okay, take out the 9, take out the half. So 9/2 integral of sine squared of 2 theta. It should be 2 theta. You get the same answer. Sine squared of 2 theta d theta. Okay, so that should be, sorry. So 1 minus cosine 4 theta over 2. Fortunately, you end up with the same answer anyway. So this was sine squared of 2 theta. So 1 minus cosine of 4 theta over 2. Bring that 2 with that 2, that's 9/4. Integral is theta minus 1/4 sine of 4 theta. I messed up, but fortunately, it's all going to be 0 anyway. So plug in pi over 2. That's pi over 2. Plug in pi over 2. Sine of 2 pi is 0. Minus plug in 0. That's 0, 0, 0. So 9/4 times pi over 2, 9 pi over 8. 7. Find points of intersection. Do they touch the pole? Can this ever equal? Yes. For instance, theta equals 0. Can this ever equal 0? Yes. Theta equals pi over 2. So they touch at the pole. Now I set them equal, and setting them equal will not give me the pole. Okay, so sine of theta equals cosine theta. So that's at pi over 4 and 5 pi over 4. Okay, you could also say tangent theta equals 1. Okay, pi over 4, sine of pi over 4 is radical 2 over 2. Sine or cosine of 5 pi over 4 is negative radical 2 over 2. But if I were to plot these polar points, they are the same point. They are 180 degrees apart. So cross out this one. So my solution is the pole and radical 2 over 2 comma pi over 4. Okay, number 8. This is squared in x, not in y, and a negative, so I know it's going to open down. Okay, it's translated 2 to the right and 3 down, so the vertex is 2, negative 3. I can write negative 12 as negative 4 times 3. So the p is 3, the focal distance. So I put the vertex at 2, negative 3. I go 3 down to get the focus. I already knew the parabola is going to open down, so the vertex is on the inside. So the focus is at 2, negative 6. I go 3 up, but it's not a point, it's an entire line. The directrix is y equals 0. Number 9, 16x squared plus 4y squared equals 64. Divide by 64. X squared over 4 plus y squared over 16 equals 1. A is 4, B is 2. That means I'm going to go 4 up and down, 2 left and right. A squared equals B squared plus C squared for the ellipse. 16 equals 4 plus C squared. C squared is 12. C is radical 12, which is 2 radical 3. That's about 3.5. Okay, so here we are. vertex 1, vertex 2, 0, 4, 0, negative 4. Endpoints of the minor axis are negative 2, 0, 2, 0. The foci are 0, comma 2, radical 3, and 0, comma negative 2, radical 3. And finally 10, you're told the foci are 0 plus or minus 13. Vertices are 0 plus or minus 5. It's going this way. That means y comes first and x second. It's centered at the origin. C is 13, a is 5. C squared equals a squared plus b squared. Some people might memorize the 5, 12, 13, but if you don't, I'll assume you don't. Put 13 here, that's 169. Put 5 here, that's 25. Subtract 144 equals b squared. B is 12, which means I put 144 underneath here. So y squared over 25 minus x squared over 144 equals 1. That's the equation of the hyperbola. Right, so this was exam number 4.